Greetings, everybody. We're back at it again. You guessed it, another video assignment for the Sonoran Desert Institute. This is another one for FTH 202. That is going to be the Revolver course for the Handgun Specialist program. Now, this is my week 3 assignment. This is going to be basically going over 2 parts. The first part's going to be some malfunctions that could, pretty much go down if certain particular parts were to fail or malfunction. And then part 2 is going to be a little tutorial on how to measure barrel twist, which is something I've actually covered in a previous video. Hopefully I do it better this time. It's kind of the idea of these videos is so I can get better at this. But I'll put a link or a card to the video that I did the first time with the AR-10 build in the screen somewhere. Got to do a quick verification that there's no live ammunition here. I keep my reloading sessions separate from my gunsmithing sessions. As soon as I'm done reloading, any live ammo goes in there locked away. Got the gun, got the tools, got other tools that you probably won't use for this video. Should be good. All right, first things first, when handling the firearm, you gotta make sure it's clear. Your revolvers, these are your chambers. You got no obstructions, no live ammo, nothing in there, no obstructions in the barrel either. First thing we need to do to get to explaining these parts is the grip and the side plate. Again, I'm going to take this one out first because this is the one that has a plunger and a spring in it. Just like we mentioned in the last video, you don't want to pry this plate up. We're going to whack it here and use inertia to pop that plate off. All right, now everything I'm pretty much going over is stuff that I've learned from the course materials provided by SDI. All stuff that we've learned in our lecture. There's 4 components that we're going to talk about today. Basically, we're going to be going over what issues you might have, like what failures you'll have if these parts don't work or fail. The first one's going to be the hand. So the hand is going to be this piece right here. Now the hand is what's going to be pushing your cylinder counterclockwise to lock into the notches. Now, a common thing that is explained to us that happens the most is an overworn hand. And basically what happens is the tip of the hand that pushes on the cylinder notch, or not the cylinder notch, but this indexer here, the hand will become worn on the surface that pushes on that. Basically what happens is the action becomes, I think it says it becomes slow, meaning the hammer becomes cocked before the cylinder locks in with this cylinder stop here. So I would imagine that a basic example would be, if you go to cock the hammer and at full cock, the cylinder can still be rotated a little bit to engage with that cylinder stop. So that would technically be a failure to lock. The next part I want to talk about is the sear. So in a double action revolver, you kind of have 2 sears, right? So you have your single action sear, which is going to be this surface here of your hammer on the very bottom of your hammer. And then your double action sear is going to be on the very edge of this spring-loaded arm here. I'll go ahead and demonstrate that for you. So single action sear engages here. Go ahead and decock that. Now your double action sear. As I said, is kind of up here. As you pull the trigger back, this arm here is part of the trigger and it's going to push up on that sear. It's going to keep pushing, pushing until it finally releases. Now, I'm going to go with the obvious one when it comes to talking about what sears can cause is I want to go into the single action, right? So on normal guns, you have them cocked, or on guns that you're familiar with, they can be in the cocked position, the cocked configuration, where it's sitting on a sear, spring loaded though. Now this is going to be your single action sear up here, as I mentioned before. Now, if these sears become extremely worn, then you can imagine that it could slip prematurely or the gun might not be drop safe, which is a huge safety concern. When it comes to sears, you got to take those very seriously. Now, as far as your double action sear, which is this arm here, a lot of this is explanatory just by observing the actual mechanics within the gun. Now, if this sear here became extremely worn, you just have to picture the hammer could fall prematurely. So say if it got to here and the hammer fell, one, it might not have the right power, the necessary momentum from the spring compression to actually fire the gun, to actually push that firing pin into the primer of the round in the chambered cylinder, or the aligned chamber, I guess. It's weird with these revolvers. Another thing that could happen is if your hammer drops prematurely because of a worn double action sear, that hammer could fly forward and strike the frame of the revolver before your transfer bar makes its way up in front of that firing pin because of how much farther your trigger has to travel back from that prematurely dropped hammer. Before I get carried away with that one, I'm going to move on to the cylinder stop. Now the cylinder stop is going to be this guy right here. It's all one piece. It's kind of hidden a little bit. It goes into like a U shape here and then another shape up here. So it's kind of like a little question mark almost. And you can kind of see it shine through. I'll try to angle, I don't know if I can angle it for the camera perfectly for you guys, but what's really happening is as that trigger moves, actuates, whether you're double action or single action, it's gonna push that cylinder stop down out of the way of the notch so the cylinder can move freely. And then that spring-loaded cylinder stop is gonna clear the trigger and go back up into the frame, catching the next notch on the cylinder, locking it. Now your cylinder stop, just like the hand, it plays a big critical role in the timing of the action of the gun. So it brings us back to a failure to lock. So if your cylinder stop malfunctions, whether it's worn or the spring here is worn, or it's just not disengaging with that sear on the trigger here, you know, you'd have timing issues and you'd essentially have a failure to lock. Moving on to the hammer strut. So your hammer strut, it's gonna be this guy right here. Now this strut is spring, it's spring compression when it's cocked. Now if this spring breaks or it just loses tension, you'll have maybe light primer strikes, so a failure to fire. You would have poor sear engagement, so it would also be a failure to lock, or no, not scratch that, a failure to cock. So cocking would be an issue there. Failure to fire is another one too. There's a lot of things that could go wrong here because you don't have that spring tension pushing up against the hammer. It really depends on how it's malfunctioning. If it's got a failure to fire, a failure to cock, lock, whatever. Everything's on display right here and you just run that thing through its cycle and you can see exactly what's going on. We're gonna go ahead and put this back together and we'll move on to part 2 of the video. All right, so for this next part of the video, going into measuring barrel twist, you're basically want to secure the firearm in a vise of some type. This one I'm using the Real Avid gun vise. So you're gonna need a couple of things. So you're gonna need a cleaning rod that's on a bearing. You're gonna need patches. Oh, and you're gonna need a jag. Let me grab one of those. Or an eyelet, standard eyelet if you prefer that. You're gonna need a solvent or a oil of some type. Well, you don't need the oil, but I'm gonna use the oil because it works for me. You need some tape and a Sharpie and something to write on. Just gonna set that guy on there just like that. Give him some oil so it'll slide in a little easier. So we're gonna set this up now. So for measuring barrel twist, you're gonna take a piece of tape, either blue, I like to use blue tape. Now I'm gonna place this right here and we're gonna make kind of like a flag with it to eyeball. It makes it easier to eyeball the degrees of turn because that's what we're gonna be doing as part of the equation for measuring barrel twist rate. Now with a barrel this short, we're gonna be doing a little bit of math and I'll walk you through that once we do it. But for now, let's just get it engaged with the bore, with the rifling. So I can see that it starts turning the rod on its own right about there, okay? So I'm gonna make a mark on the brass itself there. And we're gonna be making a second mark somewhere further down. I'm gonna shoot for 1/8 of a turn on this piece of tape, but this is black. So we're gonna have to put another piece of tape on the rod itself. All right, just like that. We're only gonna be going about right here. So we got our first mark there and we're gonna try getting 1/8 of a turn out of this flag here. And then we're gonna make another mark. So I had the flag straight up and down and now it's at about a 45, which means it's at 1/8 of a turn. I'm gonna mark that here and then we can take this out. All right, so now we got those 2 lines out. We gotta do some math here. So it started at this line and then we got 1/8 of a turn when it was at about this line. So we're gonna take that and measure it. And that brings us to about 2 inches between these 2 black lines. So we're gonna write that down. So we got 2 inches of distance of 2 inches of bore to get 1/8 of a turn. Now, what we're trying to do is we're trying to figure out how many inches of bore you need to get 1 full revolution on this flag here. Now, that's pretty simple math with this formula, with what we got here, because we just got to times this length here times 8 to get a full here. So to get full rotation, you would times 2 by 8, which gives you 16. So it's a 1 in 16 twist. So that's your barrel twist rate on this gun. Well, roughly, I kind of flew through that. So that's an average, but should be roughly 1 in 16 twist. All right, so there you have it, guys. That's a few, scenarios of, some malfunctions to get with a revolver and a little rundown on how to measure a barrel twist rate. Like and subscribe to the video so you can see some of the more big stuff I have planned for this year. And click on the link below if you want to find out more about the Sonoran Desert Institute, or SDI, that's what we call it. So peace.